I was thinking like this would be really slow, but it's so fast. It's really like on set.
Bring the noise. This is our project. Sean and I, we wanted to create an FM radio. Why? Because we like music and we wanted something kind of hard.
Okay, yeah, so we went through a variety of options before. We had a variety of receivers we could have chosen. There was AM and FM, but we decided to just go with FM. So before we picked, once we picked a receiver, we started to define some requirements for the project. So we wanted to interface with the receiver to be able to pick up FM radio stations and play the broadcast of music. So we chose the AR-1010 FM receiver, which goes on the US FM band from about 88 megahertz to 108. And then we also wanted to be able to tune to different radio stations, FM radio stations in San Luis Obispo, and be able to change, adjust the volume setting that's being output to the speakers. So we do that with two external buttons. So we have a button that tunes, and it just starts at the first radio station at the minimum at about 88 megahertz, and then goes all the way up to the last one at about 107, and then it'll roll over back to 88. And then for the volume, there's a similar thing. We have a volume range from 0 to 9, and it starts out at about 5. So as you press the button, the volume will increment and then go to 9 and roll over. We also wanted to display the volume, the current volume output, the frequency of the station that you're on, and the genre of the station. And we did that with the Nexus board and the LCD screen.
So here's our hardware block diagram. Like Sean said, using AR-1010, this demodulates the signals. We use the PMOD audio amplifier, so this is how we output the signal so we can listen to. And at first, we just wanted to use the Nexus board right here. But we didn't have enough connections to connect to the AR-1010, so we made this a little tricky. We spiced it up using a PIC 18. We used I2C to talk to the AR-1010, and then we added buttons to the PIC, so we could change the volume and the stations.
Okay, so here's a general software flow diagram. So initially the PIC initializes, well, the Nexus board will initialize the LCD module, and the PIC will initialize the FM receiver. And then it'll tune to the first station, which is lower, or at about 88.5 megahertz. And then it'll tune to the like a mid volume at 5, so it's a range of 0 to 9. And then continuously the PIC will be pulling the two buttons, the tune button and the volume button. And whichever one's pressed, if the volume button's pressed, it'll go ahead and increment the volume, and then it'll assert a GPIO, which the Nexus board will see, and change LCD display. It will then display the output volume level on the LCD display. And similar for the radio station, if you tune to a different radio station with the external button, it'll the PIC will tune to the different radio station, the receiver, and also assert a GPIO, and the Nexus board will see that and also display the new radio station on the LCD module.
So design overview. For our hardware, we use the PIC 18, the AR-1010, PMOD audio amplifier, the Nexus 1 board, the LCD, and added buttons. And for the software side,
and for software, we have code that already has been written to initialize the LCD and display radio station data, but there are functions for that on the Nexus board. And then there are also command or functions on the PIC that are used to write commands to the FM receiver through I2C to tune the radio station and change the volume. And then there's a simple GPIO interface between the PIC and Nexus, so that all the PIC does is toggle a couple GPIOs when it wants the Nexus board to change what's on the display, either the radio station name and frequency or the volume. And then there's loops that just pull the buttons, so when either of them is pressed, it will either tune the station or change the volume.
and lastly, our demonstration. Everything does work, so we can show you guys what we have. Let's bring the noise.
Okay, so this black button, the first volume setting is kind of low, so I'm gonna go ahead and increase it. The first radio station is kind of not tuned very well, but this is 89.7, which is family talk. I have no idea what they're talking about.
We have devotions in our company every Monday morning. We always say this is the most important meeting.
And this is college radio. And this is talk radio.
We're disappointed.
And that's classic rock, which is 93.3.
So you guys said you had to use the PIC because there wasn't enough output on Nexus?
Well, no, the FM receiver only has one data line. We could use SPI, but we wanted to be able to read and write to the device, which you need 2 data lines for. So we use Express C instead. And this is adult album radio. That's another classic rock station. That's top 40. That's country. Don't know what that is, but we can pick it up. That's Spanish. And there's another country.
12758.
And that's hip hop, which is 106.1. Well, we went on our website and looked up the radio station and listened to that.
So it's categorized.
Yeah, that's how we got this on there.
Sean's on the polyset, so that's why he's made it.
Yeah, and I went ahead and utilized the PIC. I've worked with them before, so I went ahead and used that.
Malawi for sure.
No.